This is problem number 3 from section 4.7. It says solve the equation and inequalities. And they give us a graph. Now, if we want to do part A, anytime we're solving an equation, we're really looking for the roots or the x-intercepts. In our case, we have one here, and one here. So our x-intercepts are our solutions here. We'll call them the roots. And I'll just say x-ints here. Our roots then are -4, -2, and let's see, 5, 6, 7, 8. So whenever we're looking to solve just a regular equation, we're looking for the roots. So if we had an equation, right, we'd go through and we'd solve the equation setting it equal to 0. But if you get a graph, well, you can see that obviously the x-axis, that's where 0 is. So we just look at where it crosses, and those are the roots. So part B then. Now this is when this changed a little bit, because this is a polynomial, right? We've done quadratics before, quadratic inequalities. Now we're doing a polynomial inequality. Nothing really changes though with the polynomial inequality. This says f of x needs to be greater than 0, meaning the function needs to be above 0. Well, 0 is this line right here, right? So it's the x-axis. So 0 is x-axis. So where's the function greater than 0? Well, the function is greater than 0 between the two roots -4 and -2. So it's greater than 0 between -4 and -2. So we can write that -4, -2 with a bracket is where part of our solution set is. But it's also greater than 0 from, looks like 8 to infinity, right? Because this is staying above 0 after 8, so from 8 to infinity. So we're going to say union 8 to infinity. So our solution set runs from -4 to -2, and then from 8 to infinity. And actually, I put brackets on these because I said that they could equal, but our inequality sign is greater than. It doesn't say greater than or equal to. So actually, I'm going to cross these out because I used brackets, and I'm just going to rewrite that with parentheses. That's my bad. You got to really pay attention to what is the inequality sign there. So 8 to infinity. Not including the roots. Now, if that were an equal sign, we would include the roots. Part C. F of x less than 0. So where's the function less than 0 at? Well, the function's less than 0 to the left of our root, to the right of this root. So it's less than 0 between roots -2 and 8, and then from -infinity to -5. So we'd say -infinity to -5, or not -5, -4, my bad, -4, -infinity to -4, union, and we would say -2 to -2 to 8. So -2 to 8. All right, because from this point to this point. I'll write that again, just write a little better because that 4 is not very good. So these are the solutions. This is the solution for f of x greater than 0. This is the solution for f of x less than 0. And this is the solution for f of x equals 0. So when we actually going to solve the equations with these, or like the polynomial inequalities, I should say, first step is to use an equal sign and find the roots. And then after that, we're just going to use the inequality sign to determine our intervals. Hope that makes sense.